Good morning everyone. We will start with the introduction of Modelsim. So before starting the programming, we will first try to create a folder in D drive or in desktop with a registration number. So we will make a folder with a registration number and click OK. Then we will open the Modelsim software. It will take some time to open this Modelsim software. So now it is open, so we will close all the unnecessary files. Whatever file is open, we will close that. So we will close all the projects, current project. So first we will create a new project. So we'll go to create new project, and here first experiment we are doing on half adder, so we will write it as half adder, and we have to select the project location. So we will go to browse, and whatever folder we have created, we will click on that and press OK. So all our files will be saved in this project location, and then we will press OK. So then we have to add items to the project. So we will go to create new file. Here we will write it as half adder. So add the file type. Here we will select the verilog and select OK. Close this. So now you can see under the projects a half adder file is been created. So edit this. Either you can do double click on this, or you can do right click and edit. So an edit page will come here, and here we will write our program. So the first experiment is to design and test verilog implementation for half adder. The objective is to understand what half adder with the truth table is. Second objective is to understanding how to create a new project in Modelsim, new verilog file, compiling and running the codes, and finally to see the output. So here is some theory about the half adder. It is a combinational arithmetic circuit that adds two binary numbers. Here we have two binary numbers as x and y, and it produces a sum bit s and a carry bit c as the output. So it takes two single binary number and adds them. So here the input is x and y. So here we will have a combination of input combination of 0 0 0 1 1 0 and 1 1. So when we add 0 plus 0, we can see we get a sum of 0 and a carry of 0. When we add 0 plus 1, we will get a sum 1 and a carry of 0. When we add 1 0, we will get a sum of 1 and carry of 0. And when we add 1 1, we can get a sum of 0 and a carry 1. So seeing the output of sum, we can see the output of sum is 0 1 1 0. So which is as the same output for an XOR gate. So here for the sum, we can see we have two inputs x and y, and we have an XOR gate for sum. For carry, we can see the output as 0 0 0 1. So that is the output for an AND gate. So for carry, we will have an AND gate. So here is the equation for sum. For sum it is x XOR y, and for carry it is x into y. So first we will do the data flow model of an half adder. So we'll copy this code in our Modelsim. So in our Modelsim, it will always start with the module and the name of the module, which is half adder data flow model. So here it will always end with a semicolon. So here we have declared the inputs as x and y, then we have declared the output as sum and carry. So we have already seen the sum as x XOR y, so we have assigned sum as x XOR y, and we have assigned carry as x and y. So in another alternative method is also there. We can assign sum and carry together as x plus y, and we will end the module. This is a sign of a comment, so whenever we are commenting, the program will not take that as a verilog code. So this we have written the program. So now we will save the program here. So now our program is saved. Then we will compile our program. We can do the compilation as here. We can select the file, compile, go to compile, and compile selected. So you can see that compile was successful. Another method is that we can right click on this. Here is a compile. We can compile as selected, or we can, if many files are there, you can do compilation of all. So after completing this process, we have to start the simulation. So we will go to simulate and start simulation. So the start simulation window will open. Here you can see a folder as work. So open this folder, expand this folder, and select half adder. So whatever is the module name here, it will appear over here. So here module name is half adder underscore data flow. So here same name will appear here. So we'll select that. So in case this object window doesn't open, so here we will go to view, and here we will select as objects. So in here the object window will open. So here we can see 4 waveforms are there, x, y, and sum and carry. So we have to add these waves. So directly you can select all and do the right click and add wave. So another window will open as a wave page. So here you can see the input sum, x and y, and output sum and carry. So we have to give the input. So here we will do the right click. Either you can use a force and assign it as 0 and 1. So here we can assign it as 0, and we will do deposit and do OK. So we will make a combination of 0 0 0 1 1 0 1 1, or we can take a time period. So here we will do, for that, here we will do right click, we'll press on clock. So first clock we will take it as time period as 5 and press OK. And for next input y, we will take a clock and take a period of 10 and press OK. After all inputs are declared, we can straight away press F9 in our keyboard, or here we can press, we can see here as run F9. So we can press that and press this. We can see some output is there. So we will click on here and we will press zoom in. So we have already seen when all the outputs. So for 0 0 we can see input 0 0, the sum is 0 and the output is also 0. For 0 1, the sum is 1, output is 0. For 1 0, sum is 1 and output is 0. And for combination of 1 1, we can see the sum is 0 and the carry is 1. So this is the complete simulation of our Modelsim. So after this we'll close the window and simulation will stop, end the simulation. Thank you.